So till now we have discussed about various things like divergence, curl, gradient, surface integral, line integral, volume integrals. Yes. Now in this video I will be kind of giving you the summary of whatever the work we have done till now. And most importantly, I will be giving you the formulas in the form of general coordinate system so that you can apply these general formulas for any particular coordinate system. Okay. So for example, I have written down a general vector, A vector, and the coordinate system which I am taking for now is u1, u2 and u3. Okay, so these u1 cap, u2 cap and u3 cap are the unit vectors in the direction of u1, u2 and u3. Now if you apply the general coordinate system for Cartesian coordinate system, then u1, u2, u3 would be simply x, y and z. Yes. And in the case of cylindrical coordinate system, these u1, u2, u3 will be rho, phi and g cap. And similarly for the spherical coordinate system, these will be r, theta and phi. Yes, so this is very simple. So I am taking a general case u1, u2, u3. You can apply these u1, u2, u3 or you can convert these general formulas for any particular coordinate system you want to. And I have written down the formulas for curl, gradient, divergence, and the line integral. This is the line integral. These are the surface integrals, and the line elements and the surface element and the volume element. Okay, so now in order to know these formulas or in order to calculate these expressions for a particular coordinate system, you have to get, so you know the u1, u2, u3. What are the u1, u2, u3, and what are the h1, h2 and h3? So these are kind of some scaling factor. These are kind of matrix. So this table here is giving you the values of h1, h2 and h3 for each coordinate system. So for Cartesian coordinate system, these h1, h2 and h3 are simply 1, 1, 1. Okay, so there is no scaling factor. So for Cartesian coordinate system, we have discussed most of these formulas. Now in order to get these formulas for cylindrical and the spherical coordinate system, you just have to use the different h1, h2, h3. Okay, so these are the value of h1, h2, h3. Now let's calculate the gradient. Okay, so for give you the sense how to apply the general formula for a particular coordinate system, let me give you the example, and let's calculate the gradient for cylindrical coordinate system. Okay, so I have copied down this formula below. Okay, so this is the formula. So this is the formula for gradient. Okay, and let me make it. Yes, now you can see. So this is the formula for gradient. Yes, and let's apply this formula for a cylindrical coordinate system. And we saw for cylindrical coordinate system, the h1, h2 and h3 are 1, rho and 1. You can see it from a table. Okay, so from table cylindrical coordinate system, it is simply 1, rho and 1. Okay, now let's apply. So u1, u2 and u3 for cylindrical coordinate system would be rho, phi and g. Yes, so and the vector in the general form, it will be given by, so it will be given by a1 rho cap plus a2 phi cap plus a3 g cap. Yes, so any vector in the cylindrical coordinate system will be given by this vector. Okay, so here I have written down this vector A. You can see, so this is the vector A for any general coordinate system. So you just put the u1, u2, u3 as rho, phi and g. You will be finding the general vector. Okay, so this is very normal thing. Okay, you can easily understand this thing, I hope. Okay, so once we have this these three things, let's calculate the gradient. Okay, so gradient in the cylindrical coordinate system, just put u1 would be simply rho cap. Yes, and at del A divided by h1 is 1 and del u1 would be simply del rho. Yes, plus u2 would be phi cap, yes, and del A divided by h2 is simply rho, and del u2 means del phi, yes, plus u3 cap means g cap, and del A divided by h3 is 1, and u3 would be del g, yes. So this is very simple. Now we have converted this general formula for gradient for a particular coordinate system, which is our cylindrical coordinate system. Okay, so in this manner you can convert any formula which I have written down for curl, gradient and the divergence. So this is our curl, this is our gradient, this is our divergence. You can convert this formula for any particular coordinate system once you know this table. So you just have to remember this table, okay? And you might be able to easily remember these h1, h2, h3 for these coordinate system, because we have discussed in the case of line integral, yes, in the case of line integral and the surface integral case, okay? Similarly, let's look at these line element, surface element and the volume element. So this is the line element and this is the surface elements and this is the volume element, okay? So for example, for the Cartesian coordinate system, these h1, h2 and h3 are 1, 1, 1. So dv would be simply dx, dy and dz, because h1, h2, h3 and are 1, 1, 1, and u1, u2, u3 would be simply x, y and z, yes. And for, let's say, cylindrical coordinate system, dv would be h1, h2, h3 multiplication would be rho, because it is 1 rho and 1, and simply d rho, d phi and dg, yes. So this is very simple, rho, d phi and dg. So in this manner you can convert these formulas for any particular coordinate system, okay? So I have written down all these formulas. You can just pause the video and you can note down all of these formulas, and you should be able to remember these formulas, because once you are solving any problem you have to apply these formulas. And also let me tell you, don't just mug up these formulas. Try to analyze these formulas with the help of Cartesian coordinate system, maybe particularly, because it is very simple to analyze, and because you need the 3D visualization approach in your mind. Once you are applying these formulas, you should be knowing what is the theta, what is phi, what is the direction of rho, what is the direction of g, okay? All of these things we have discussed in the previous lecture. Otherwise I could have given the direct formulas instead of wasting all of these previous lectures, but this is very important to understand all of the theory just before the formulas, okay? So okay, hopefully you will be applying these formulas and will be able to solve the problems in much faster way now.